Hello and welcome, everyone. My name is Dane Menke. I am the Digital Marketing Manager here at Regenesis and Land Science. Before we get started today, I have just a few administrative items to cover. Since we're trying to keep this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If the webinar or audio quality degrades, please disconnect and repeat the original login steps to rejoin the webcast. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we don't address your question within the time permitting, we'll make an effort to follow up with you after the webinar. We are recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's presentation will focus on large-scale vapor intrusion projects, with an emphasis on overcoming challenges and collecting consistent quality data. With that, I'd like to introduce our presenters for today. We are pleased to have with us Jim Fineis, President and owner of Total Vapor Solutions. Total Vapor Solutions provides a full range of services dealing with vapor intrusion sites. Services include work plan development, sample collection, risk analysis, and mitigation consulting services. In addition to providing all of these services, Jim is an instructor in Hartman Environmental Geosciences Practical Guide to Vapor Intrusion 2-day course. The training has been given to over 20 regulatory agencies and over 500 students. Additionally, Jim speaks at various vapor intrusion conferences each year. Recent projects have taken him to 30 states and over 3 countries. We're also pleased to have with us today Jordan Knight. Jordan is the Southeast U.S. District Manager of the Land Science Division of Regenesis. Jordan's role includes providing technical support in the design and installation of geoseal and retrocoat vapor mitigation systems, and educating the environmental community on advancements in vapor intrusion barrier technology, implementation, and quality control by making presentations to environmental firms, regulatory agencies, and developers. Jordan has experience managing brownfield and landfill redevelopment projects where vapor intrusion barriers and venting systems have been implemented throughout the United States. All right, that concludes our introduction, so now I'll hand things over to Jim Fineis to get us started.
Thank you very much. Well, welcome everybody. Good morning, good afternoon, depending on where you're located. I'd first like to take this opportunity to thank Land Science for the opportunity to present today. Hopefully everybody will find the information useful. And we're basically going to cover 2 different large case scenarios where multiple samples were collected, and then we'll also briefly touch on what I consider some of the key points to collecting high quality data. All right. Okay, there we go. Thank you. So the items we're going to cover today and some of the challenges that we're going to be addressing are just the sheer size and duration of the projects, communication challenges, whether it's with residents, local media, regulators, clients. Also, we want to touch on how do you maintain high quality, consistent data. Some of the key issues that we'll dive into are sample storage, security, sample receiving, and shipping. You'll see some of these projects had close to 1,000 SUMA canisters, so that can present its own challenge. Laboratory capacity issues. Even the largest labs in the country might have an issue providing enough SUMA cans on a timely basis. What do you do with the mass quantity of data that you've collected? Once the data's in, what all does it mean? And then ultimately, we're trying to figure out whether mitigation occurs. And once we get to mitigation, Jordan will be taking over and talking about those, but that's kind of what we're going to cover. So let's delve into it and get into the nuts and bolts of it. So the first project that we're going to be discussing today, just trying to give you a little bit of an overview. The project was located in Metro Atlanta. It required over 18 months of commitment, mainly in like 3 to 4 month tranches. You'd have a break, then it would require, further commitment. We'll get into some details on the exact numbers coming up, but there were hundreds of 6-liter SUMA cans and hundreds of 1-liter SUMA cans required to complete the project, hundreds of trips to individual homeowners or commercial establishments. Additional scope items were added, about a third of the way into the project, which increased the time required by about 33%. So it added an additional day to every time you went to sample a house. So that was kind of a change in the middle of a project that you had to be able to adapt to and still maintain good quality data. As we can all imagine right now, with it snowing Las Vegas and polar vortex in Chicago and 10 days of solid rain in Atlanta, poor weather conditions can certainly cause scheduling issues. And in addition to scheduling issues, you're dealing with homeowners, and things happen in people's lives which can also affect the schedule. So for those items, you just have to be flexible. The last one was that, since we were dealing with, at the time, a former military base, changing security protocols, getting on and off base also, provided an additional challenge. So we're going to delve into each of these items more as we move along, but that's just to give kind of an overview. All right, so the first challenge is it was very high profile. And by that I mean there were numerous times where we were on site in the neighborhoods and had local news media following, taking pictures, wanting interviews, calling you after hours and saying, hey, off the record, what about this? What about that? Those are kind of things that obviously the road that you just can't go down. So it was very high profile. Every afternoon I had to give updates to the consultant that I was fortunate to be working for, and updates were going all the way up to the Pentagon. So there were 3 or 4-star generals in the Pentagon looking for updates as to what was going on. So very high profile. We'll cover a little bit of that, show you some of the news media coverage as we progress. Geographic challenges, there were 2 separate plumes, one on the north side of the former military base, one on the south side of a former military base. I've got a few maps to kind of show you the geography of that. And due to homeowner availability, houses couldn't be scheduled all on the north side or all on the south side. So it would have been nice if we could have said, these 5 houses are going to be sampled in the morning, but you can't interfere with the normal life of a lot of these residents. So you'll see an interesting map coming up about how much zigzagging and tracking there actually was going on in order to get the project accomplished. All right, another issue that I briefly touched on was the SUMA canister availability. It was a large nationwide lab that was selected, but getting enough SUMA cans from time to time was an issue. Additionally, you had to have time to get all the chain of custodies filled out for sample pickup and delivery. We wanted to make sure we maintained good chain of custody control, so we were always there when SUMA cans were delivered or when they were released back to the laboratory. So that was a challenge as well. The quality of laboratory hardware varied depending on which lab within the chain of the national lab sent us the SUMA canisters. So depending on which of the air labs within that chain sent the canisters, we had some hardware issues that we had to overcome. Securing the SUMA canisters was a big issue. How do you secure hundreds of 6-liter SUMA cans at a time? Transporting them back and forth to houses. So there was a lot of logistics that had to be overcome in order to complete the project successfully. I'll show you what we call the pro tips or the solutions. So each of these items we're going to go through in a little more detail and kind of give you the solutions that were occurred. Great. So to cover a little more about the sheer size of the project, look at some of these totals. So there were 102 homes that were sampled. 83 of them were sampled twice. 19 of them were sampled once. In addition to the 83 that were sampled twice, if you remember a couple slides back, I said that probably a third of the way through, the removal of household products, which in my opinion should always be done if you're going to do indoor air sampling, was added to the project. That occurred because the original work plan that was approved did not include the removal of all chemical products from within a household. So what happened is samples were collected from quite a few households, and as we all can imagine, levels that exceeded the applicable thresholds came back because, as we turned out, it was household products that were the sources and not really, soil vapor or indoor air contamination. So about 95% of the exceedances disappeared once we went back and resampled after having removed the household products. Now, having said that, as you can imagine, removing household products is very invasive. So these were all off-base homes, not on base, where the military could say, hey, you have to do this, hey, you have to do that. So, access agreements were granted, but to go into people's houses with clear plastic totes and get into every cabinet, every closet, every drawer looking for mothballs, solvents, it was on average about 5 of the large totes like you could buy at Walmart or Home Depot that were removed from each house prior to sampling. The houses were then allowed to ventilate for 24 hours before the SUMA canisters were put in. Since it was residential, most of the structures, that required a 24-hour time period for the sample collection. So as you can see, day 1 was product removal, day 2 was installation of the SUMA canister, day 3 was removal of the SUMA canisters, and then here's the thing that none of us thought about initially was putting back all the chemical products. So once you bring these totes back in, rightfully so, a lot of homeowners wanted you to put them back close to where you found them. So in addition to photo documenting to show what was being removed from the house, we kind of varied what we did and photo documented approximately where the products were, so when we went to put them back, you could handle that. Roughly 115 separate mobilizations occurred to complete the project. 375 helium leak tests were performed. That's obviously on the soil gas or sub-slab implants, and we'll cover that shortly. 400 6-liter SUMA cans were deployed for indoor or ambient air collection. Another 175 6-liter SUMA cans were deployed for crawl space sample collection. One thing to note here is for those 575 SUMA canisters, they're all individually certified. So even once again, with some of the large laboratory chains, which may have thousands of inventory, individually certified cans, take longer for the lab. So that was part of the issue we had to really carefully schedule with the lab, which then meant we had to sometimes alter schedules with homeowners. So it was really a balancing act. As you can see from the 175 6-liters that were deployed for crawl space samples, a lot of these homes were on crawl spaces. So that's why there were only 50 sub-slab implants installed. So any of the homes that had basements, we installed sub-slab ports, normally 2 ports per home. Any of them that had crawl spaces, crawl space samples were collected. In addition, out within the neighborhood and on the base, approximately 290 soil vapor points were put in. They ranged everything from as shallow as 2.5 feet to deeper locations if you're looking to see whether it was a groundwater source or a soil source. So there were a lot of vertical profiles done as well as shallow soil gas. But that's another 290 samples. No matter if it was a 1-liter or a 6-liter, we always perform what we call a shut-in test to make sure that where the flow controller attaches to the SUMA canister, that connection is good and we're not going to get in ambient air or bypass the regulator. So it's referred to as a secondary leak test or a shut-in test, and approximately 650 of those were conducted as well. So that just gives you an idea of the sheer number of samples and what had to go into even getting ready to collect samples. Next are just a couple maps. Doesn't really matter, but it's just showing you, in this one, all the houses in yellow were primary houses that needed to be sampled for whatever reason. The other houses were secondary houses, but the point of the next 2 slides is just to show the yellow line is a groundwater plume, so they were looking at certain homes within, the groundwater plume, but this would be on the north side of the base. The second slide is on the south side of the base. So as we get a little further on and you see some of the zigzagging that had to go on, this is what we're referring to. It was probably, 3 or 4 miles between the north and south side. So you had to account for that traffic and the commute time if you were going to sample home 1 at 10 a.m. on the north side, there's no way you could be down by 10:30 on the south side to sample home 2. So if we could have stayed to the north side or the south side, it would have been great, but that's just not what the project allowed. So you had to be able, willing, and flexible to go side to side, north to south, south to north. All right, so the sheer size and duration of the projects. What is the solution? It sounds crazy, but you have to have a plan and you have to be organized. So the consultant I was working for did a great job of providing daily schedules, allowing you to know when you needed to be, where you needed to be. So scheduling is absolutely critical. You know, the 100+ houses, multiple rounds of sampling, you know, organization was the key. So we would have a kind of a kickoff morning, a kickoff meeting every morning where we looked at the schedule. The consultant would double check with the homeowners to make sure everything was going to be okay, that nobody, you know, nothing had happened. So organization is key. You'll hear me harp on this a couple times, but consistent personnel is mandatory. So if you're collecting this many samples, if there's variability in the way they're collected, then that's going to increase the variability in the data. So to keep as few people as possible to collect the data, to make sure you can maintain consistent protocols, make sure internally you have good SOPs, make sure everybody's doing things the same way is very important. What surprised me was that the relationship with residents probably turned out to be the key. You really had to go out of your way. We joked that there were a lot of homeowners that we would go to first thing in the morning, and they would have, you know, biscuits and gravy cooked for us. They'd want to tell us about their granddaughter or grandson. They want you to play with the dog. So building a relationship with the homeowners is very valuable. And to that extent, you know, something to pay attention to is it was amazing how often people were watching you when you're in the neighborhood. So whether it's stopping at a stop sign, not speeding, just, you know, being a good citizen went a long way to show respect to the neighborhood. So those kind of items are very important with business owners trying to work around their schedule, their breaks, those kind of things are really important. So that was one of the solutions, is really just being organized, having consistent personnel, and developing good relationships with the clients. Second challenge, the proper management of SUMA-cans and the availability. Like I mentioned, there were 865 SUMA-cans used for the project in total. Ambient air, indoor air were all 6-liter SUMA-cans, individually certified. Soil gas were 1-liter SUMA-cans. Everybody's seeing, but the little photographs just showing you for a similar size box how many more of the smaller SUMA-cans you can actually have than the larger ones. But the sheer volume was a challenge. So we'll go through a couple different solutions. One is you have to have a secure place to manage your equipment. It could be a variety. On this project, as you'll see next, we were able to commandeer a building that had a, you know, a secured fence area inside. There have been places where I've had to rent hotel rooms and only, you know, the members of the team had a card, and we had to keep all the SUMA canisters in a hotel room. We've even had to go to renting a used storage place, you know, put our own lock on, you know, put a security camera inside so you could see everybody that's coming and going. So when you're dealing with large scale projects, hundreds and hundreds of SUMA canisters, how you manage them is key. Because the bottom line is, if you don't maintain the proper chain of custody for the life cycle of your canister, then the data can become in question. You know, we're all looking at very low screening levels sometimes, so maintaining proper chain of custody is absolutely critical, and securing the samples is very important to make that occur. This is an example of what we were able to commandeer. So there was a nice fenced lock area inside of a building, and we were able to, you know, secure it so you can see through the SUMA cans in there. There were only 3 keys. The consultant had one, I had one, and, you know, the laboratory had one. So there was very limited, you know, egress and entrance. So you just have to find a secure place to have your SUMA canisters. Another challenge, I mentioned very high profile. You know, these are just a couple screenshots of some of the news media. So as I mentioned, didn't matter what the network was, national, local, they were following you around. And what really amazed me is that we would find them sitting behind us at a restaurant when we were having lunch, trying to overhear, you know, what we were saying. So just be aware, if you're dealing with high profile, whether it's a military base, whether it's an environmental justice job, no matter where you are, be aware that people are trying to listen. So I mentioned I would get calls on my home phone saying, hey, this is so-and-so, or not telling you who they are, but asking questions, or just be very careful, because with the intense media coverage, you just have to be aware. How do you solve that? Communication and paperwork. So you need to have all your ducks in a row before you start. So these are just 2 example documents. You know, there is the EPA Occupied Dwelling Questionnaire, which I recommend anytime anybody's collecting indoor air samples, ambient air samples. You know, it's a great questionnaire. You can make some modifications if you need to, but having that in place will help. Access agreements are key. These were all private residences or private businesses. So fortunately, this is something that was handled by the Corps of Engineers and the consultant that was working on the job. But, you know, you don't want to be going in places if you don't have access agreements. And a lot of times, you know, the homeowners would say, oh, we're going to turn in the access agreement, and they never did. So once again, just having your ducks in a row, having good communication paper trails, and making sure your paperwork is in order was a very key function. Another solution was you got to kind of stay up to the times. Social media was very important. So we would put out notifications in the newspaper, email fact sheets, do Twitter updates, Facebook updates. Hey, we're going to be in the north side today. We're going to be on the south side today. Some residents, most of them were slightly older, so they didn't want to receive text or email. So even within the community, you've got to kind of learn to know who your customer is or who you're dealing with, and learn to communicate with them on the method that's best for them. Can't just say, we're going to post to Facebook, and if they don't get it, tough. That's not the kind of way that you can communicate. So communication was very, very important. The thing that surprised me most was giving the residents their results. So obviously, when the collectors are out in the field, every resident says, hey, how long before I get my results? You know, we were always told to say somewhere around a month, but here, call the vapor intrusion hotline, and we may be having a technical issue, so hold on just 1 second. Okay, I think we've got the technical issue addressed. Sorry about that slight delay. As I was mentioning, when you are talking to homeowners and saying, hey, you'll get the results in a month, it was amazing how many would put that on the calendar. And if the results were not within a month, then next time you came back to sample, you kind of lost some trust. So keeping trust with the homeowners meant just, you know, being honest with them, but having a realistic expectations as to when they could see the results. And then how do you convey the results? You know, in this project, they did it a variety of ways. They would have a community meeting where each homeowner had their own packet. The homeowner would show up, and their individual results were only discussed with the risk assessor or the consultant, because, you know, it is privileged information, and people didn't want necessarily their next door neighbor to know what their results were, because maybe you could affect property values. Maybe you had other issues like that. So being transparent with the homeowners, but not sharing too much information was, you know, very critical. So communication is always key. All right, geographic distances. Next couple points will just show you that we had the two plumes, north and south side. Homeowner availability meant we had to make multiple trips. The next slide may shock you a little bit, but if you don't think Google is tracking you, then turn tracking off on your phone. So I intentionally knew that the Google tracking was on, but this is just an average map for an average day when we were collecting samples. So if you happen to look to the lower left and the upper right, one's a Chick-fil-A, one's a Quick Trip. So you could see that we did have breaks and downtime, but you can see how many zigzags in an average day. So it averaged out to be about 60 miles a day just going back and forth between homes. So it is time consuming, but it's just a necessity. So it worked, but it was very taxing for sure. In conclusion on this project, you have to have teamwork between the consultants, regulators, responsible parties, contractor. It's mandatory. If you don't have teamwork, then these projects are not going to be successful. Flexibility, allowing field staff to make adjustments. As we moved along, you know, the consultant who normally had somebody out there with me would allow us to make, you know, changes to the schedule based on, you know, this homeowner would text or call us and say, my grandson got sick and we've got to go to the doctor. Okay, you know, not only does it affect the schedule for that day, but it affects the schedule for the next 3 days. So just communication and having some flexibility. One take-home message is patience. We're dealing with people, dealing with weather, dealing with instrumentation, dealing with suma canisters. You're going to have patience because that's just what it's going to take. Consistent personnel, again, is key to making it work smoothly, in my opinion. So we were very fortunate, basically had one point of contact with the Corps of Engineers. You know, the consultant, I had 2 different people I was dealing with, and then, you know, the field staff was very consistent. All right, let's look quickly at another project, not nearly as much detail, but overview is it was a bank portfolio purchase in Wisconsin, 10 branches located across the state. Work had to be completed in a week. As always, project cost is a concern, rightfully so. We were only allowed to work bankers hours, 9 to 5. Equilibration time for sub slabs, which all of these projects included, ranged, you know, a minimum of 2 hours. If you listen to the Wisconsin guidelines, some other guidelines might say up to 8 hours. Bottom line is you couldn't drill and sample in the same day and try to get to all 10 sites within a week. In addition, the client was very forward thinking and they wanted to collect slab specific attenuation factors. So if we got back results from the sub slabs, we could apply a site specific slab specific attenuation factor and not have to use the default 0.03 from the EPA. Very forward thinking. Yes, it costs money, but in the long run, it turned out to be a very wise choice. Give you an idea of the geography. The stars represent the 10 locations. So you can just see that they were north, south, east, west, trying to install, sample, drive, everything, you know, could be challenging. How challenging? Once again, Google tracks. So these are just, once again, a couple tracks from, you know, the phone that I was using, but over 1,300 miles in a 6-day period. All 10 sites were sampled and installed in 6 days. 28 sub-slab samples and 40 slab attenuation samples were shipped to the laboratories, the appropriate laboratories. So it meant a lot of driving, but it could certainly be done. You know, what were really the solutions? Once again, communication. The client did a great job of letting all the bank branches know that we were coming, we would need access, what we were doing. So when we showed up, there really weren't many surprises. The client had a representative with me all the time to facilitate access, help with sample packing, so it was great to have an extra hand. The laboratory did a fabulous job. Since we had 10 different sites, they provided 10 different boxes, 10 different shipping labels, 10 different prepaid shipping labels, and pre-filled out chain of custodies other than the sample IDs and that kind of information. So it was very easy once you finished a job to box up your samples, ship them off, and be done. The slab attenuation lab worked around the project schedule, accepted samples on the weekends, really went above and beyond to make the project happen. And the key was we could only work on site during banking hours, but we used the non-banking hours to use as drive time or sample prep time or other items like that. So those are just two large portfolios, one completed within a week, the other one completed over an 18-month period. So no matter if it's a one-day job, 1 week-long job, or an 18-month-long job, how do we go about achieving high-quality data? These are some of the keys. Higher experience. In my opinion, the laboratory is one of the keys. Very important. The sample collector, you know, if they haven't done it, then you're probably going to get diluted samples. You just don't know what you're going to get. Make sure the risk assessor is, you know, familiar with the applicable risks in the different states, because what we see is that, you know, let's say this risk assessor does a lot of work in Colorado and they start to go to Florida, and the cancer risk values level is different. The non-cancer risk value is different. One state may have screening levels, another state may not. So just be aware of where you're working, because that always helps. Second bullet, always have a backup plan and equipment. Did a project in Mexico, and when I tried to go across the border with Suma canisters, helium, and a helium leak test, border guards would not let them through. So that would have put the project on hold. But as a backup, we had Tedlar bags and another leak test method that was able to go across the border. So we went across the border, did the work, came back to the US side, transferred from the Suma canisters to the Tedlar bags, or Tedlar bags to the Suma canisters, and everything was fine. Consider on-site analysis if you can. That's always great. Using proper techniques, tubing types, equilibrium times, construction methods. The data collection and management, be consistent between sample collectors to achieve the best data. Think outside the box if necessary. Consider alternative methods. Consider using a data collection app if you need to. Collect enough data. Some of the following slides will show you that more data is usually better. So I've got about another 4 or 5 slides and we'll get wrapped up, and Jordan will take over. So the data collection app, here's one that I use, and these are just 3 screenshots to give you just an idea. There's a lot more data than this within the app, but you can see you have project information. A lot of it can be drop-down tabs. At the end, you can sample as the installer. You can have your client sample. You take photographs of the chain of custody, photographs of the shipping labels, and when the project's done, you simply hit a button, a PDF report is generated, and it goes right to the client. In addition, you can obviously see you have boring numbers, photographs of the locations, longitude and latitude. There's probably 45 to 50 different pieces of information that gets put into the app. So this really helps maintain high quality data, because you're always answering the same questions, you're using the same format, and makes it pretty easy. One more thing about the app is it makes it nice is it can show you where the projects are, and if you want to know where one of the projects are, you can look at it in both map view and list view. So it's just a nice way of visually representing, and then if you're in the field and a client has a question, it's easy to go through since it's done on a mobile device, a tablet or a phone, and look at the data, give them the answer, reshoot a PDF email to them if they need to. So consider some kind of app. There's, you know, probably quite a few out there. This just happens to be one that I use, or you could certainly develop your own. So last few slides, I want to talk about achieving high quality data. A lot of you are familiar with VaporSafe, Dr. Hartman and Dr. Cram. I have no vested interest in it. I just think it's a great technology. Here's a plot that shows, you know, what does one data point tell you? So if you go out and collect a Suma canister for 8 hours or 24 hours, what does it tell you? Look at the immense variability. This happens to be PCE that can occur within a day. So I can speak for myself saying I've been very surprised at the variability with inside indoor air within short time frames, within hours, certainly within a day. You know, sometimes it's kind of, you know, a little bit scattered like this, or sometimes you can see relatively consistent patterns. But in this case, this is TCE, and you can see that the values can change 20 to 50 times. So if you collect just one data point, Do you get it at the high point? Do you get it at the low point? And no matter where you get that data point, is it truly representative of what's going on? Just something to think about. So on certain sites where you need a robust data collection program, I'm a big fan of the VaporSafe. In addition to looking at contaminant data, you can start to do some correlations. This one you'll see there's PCE on the top, barometric pressure, and wind speed. So if you look at this one, when the PCE goes up, looks like the barometric pressure is dropping, looks like the wind speed goes up. You can start to learn correlations, especially on sites where maybe that they monitor for multiple days or a week or a month. You can really start trying to figure out what could be causing these episodic events. Sometimes it could be HVAC, sometimes it could be weather related. You won't know unless you know that the events are occurring. So it allows you to look at that data. That wraps up the part of the presentation I wanted to mention. Once you look at all this high level data and see that you need to do mitigation, what does that entail? So at this point in time, I'm going to turn it over to Jordan with Land Science. She's going to go over some mitigation options, and we'll go from there.
Great, thanks, Jim. For those of you that may not be familiar with Land Science, we are a division of the global remediation company Regenesis. Land Science is comprised of engineers, scientists, and technical sales managers who have developed vapor intrusion mitigation technologies that are proven to protect human health while revitalizing contaminated properties. Land Science, we're working with vapor intrusion on a daily basis and want to leverage our experience to assist in redeveloping brownfields and environmentally impacted sites through the use of our technically sound and cost-effective solutions. Land Science has developed 3 core technologies for vapor intrusion mitigation. The GeoSeal barrier systems are composite barriers predominantly designed to be installed sub-slab for new construction scenarios. VaporVent is a low-profile vapor collection system that can be used in lieu of slotted pipe for active or passive vapor collection. And RetroCoat is a proprietary vapor intrusion mitigation coating system. RetroCoat is intended to be installed directly on top of an existing concrete slab. Land Science offers industry-leading warranty options for its vapor barriers and mitigation technologies, including material and system warranties with durations up to 30-year material warranties and up to 20-year system warranties for the GeoSeal vapor barrier systems. Extended warranties require site-specific evaluations by Land Science prior to installation to determine which warranties can be offered. Segueing off of Jim's conversation with taking vapor intrusion samples at existing buildings and existing homes, oftentimes mitigating existing structures with vapor intrusion concerns can be much more complex than when you're dealing with a new construction situation when you have a clean slate. Each existing structure offers its own set of unique challenges. Again, to segue from Jim's conversation, if there is a vapor intrusion issue and that is identified at an existing building, there are a few different options that you can begin to evaluate. The most common mitigation approaches for existing buildings can involve installing an active sub-slab depressurization system, incorporating a vapor intrusion barrier system in conjunction with a concrete capping slab, or installing a vapor intrusion coating system such as RetroCoat onto the existing concrete slab surface. The research and development team at Regenesis evaluated over 1,000 different coating, resins, and sealant formulations in order to create the RetroCoat system. RetroCoat is the first coating designed, tested, and approved by the regulatory community to mitigate contaminant vapor intrusion in existing buildings. RetroCoat is chemically resistant versus PCE and TCE and is currently the most chemically resistant vapor intrusion barrier available. RetroCoat could be an ideal mitigation technology for existing buildings since it can be used as a wearing surface. It can withstand forklift traffic in industrial settings, or it can be covered with other flooring systems such as carpet or tile if you're dealing with either a commercial or residential building use. Additionally, RetroCoat contains no VOCs in its formulation, so it's not going to off-gas after application. Oftentimes, other coating products or off-the-shelf materials will actually off-gas after application. So when you're evaluating coating systems for vapor intrusion mitigation, this is one important characteristic to address. Coatings that are formulated with VOCs can create persistent indoor air issues post-application. Chemical resistance is another critical characteristic when evaluating vapor mitigation barrier systems. It's important to confirm that the mitigation barrier being installed, whether it's for an existing building or a new construction scenario, it needs to be proven to be resistant to the contaminants of concern at your site. So these are the specific diffusion rates for RetroCoat. They are indicated in a rate in meters squared per second at which PCE and TCE could pass through the RetroCoat system. As you can see, these rates are extremely low and they meet regulatory suggested levels for chemically specific diffusion rates acceptable for vapor barrier systems. So now we're going to talk about the actual application process for RetroCoat, which is relatively straightforward. First of all, any existing flooring systems will need to be removed from the building and from the existing slab. The next step in the process is going to be either the engineering and consulting firm or either our certified applicator or another testing company coming out and conducting a calcium chloride test on the existing slab. A calcium chloride test follows ASTM testing method F1869, and this is going to help determine the moisture vapor emission rate across the area expected to be sealed. So moisture testing is going to help us determine at Land Science which primer is going to be required to ensure proper adhesion of the RetroCoat system to the concrete slab. So once that has been determined, a certified RetroCoat applicator is going to come out, conduct the surface prep and RetroCoat system installation to ensure a high quality application. The RetroCoat applicator will prepare the concrete by either shot blasting or diamond grinding the slab to remove any existing adhesives, other epoxies or paint that may be on the concrete slab. Ultimately, they want to achieve a clean, open concrete surface for the RetroCoat system to bond onto. After the surface prep is completed, any imperfections or cracks are going to be treated with the RetroCoat gel. Then the primer is going to be applied, and this is again based on the results of those calcium chloride tests. Either the primer is going to be installed at a thickness of 6 mils, or it may be required to be installed at a thickness of 20 mils. Once the primer's been installed, RetroCoat is going to go down at 20 mil. There's an optional aesthetic top coat that can be installed, referred to as the top WB coat. And this, again, can be added to the system if it's desired by the owner or if RetroCoat is going to be the wearing surface. And I will get into that a little bit more here in a minute. And then really lastly, any penetrations through the slab and the building perimeter can be sealed with our RetroCoat caulk material. So Land Science, we've been involved in over 1,200 vapor intrusion mitigation projects. Nearly 200 of those have been RetroCoat applications. As Jim's topic entailed, we want to be talking about more large-scale vapor intrusion mitigation applications. One that I'm going to talk about here was a 50,000 square foot RetroCoat application. This site was particularly challenging due to the fact that there was an operating manufacturing facility with workers operating inside this building 24/7. The facility had previously installed just a generic polyurethane coating system on its floors that had been peeling off and was unable to withstand the forklift traffic and day-to-day activities inside the warehouse. Due to the historic use previously at this property of chlorinated solvents, the owner had elected to install the retrocoat system at this site due to its durability and the ability to protect their workers from potential CVOC vapor inhalation. So part of that challenge that I referenced of overcoming the 24/7 worker schedule, really the solution was Land Science working directly with the EH&S facility as well as our retrocoat applicator to help sequence a multi-phase installation approach at this site. Our retrocoat applicator, they were able to accommodate a 3-day installation turnaround for the areas that were provided, and those were often during holiday weekends. So just like Jim had mentioned, you know, teamwork, communication, that is very critical even once you get into the actual installation of your vapor mitigation systems. So keeping open lines of communications with all parties involved, you know, the engineering firm, the actual building owner, and then of course with Land Science, that really helps these applications go much more smoothly. So in these photos here, these are actually of this site where the retrocoat gel was being installed in the cracks at the facility floor, followed by the primer in one of the manufacturing bays. So once the primer was applied, in this case only at 6 mil, retrocoat was installed at 20 mils with a slotted squeegee, and then it's back rolled to achieve a smooth finish. You can see the original polyurethane coating on the left-hand side of this image, which has faded, and you can also see some yellow striping, and then the retrocoat system is on the right-hand side in the white. So also at this site, what was unique was with retrocoat designed to be the wearing surface, the facility had elected to incorporate the aesthetic top WB layer into this retrocoat system. Again, the top WB layer is designed to protect the bright color of the retrocoat system. If retrocoat, that layer is just exposed without the top WB, the aesthetic look of the retrocoat can amber or fade over time just due to exposure to fluorescent or UV light. So by incorporating the retrocoat system with the top WB in this case, the facility now has a durable, chemically resistant, and beautiful floor system protecting their workers. So if you or your firm are looking to get involved in or are currently developing vapor mitigation system designs for your future projects, whether it's a new build application or an existing building scenario, Land Science, we're here to help provide design assistance for you. We can review your site conditions, the contaminant concentrations present at the site to help provide recommendations for passive and active venting layouts, along with the appropriate vapor mitigation barrier design. We can offer a suite of CAD drawings, cut sheet diagrams, and specifications to help create a customized approach based on your site's conditions. So please do not hesitate to contact us if you would like to learn more about how Land Science can assist you with your next vapor intrusion mitigation project. And that concludes our portion of the presentation.
All right. All right. Thank you very much, Jordan. At this point, we would like to shift into the question and answer portion of the webcast. Before we do this, just a few reminders. First, you will receive a follow-up email with a brief survey. We really appreciate your feedback, so please do take a minute to let us know how we did. Also, right after the webinar, you'll receive a link to the recording as soon as it is available. All right, so let's circle back to these questions here. We have a lot of questions today. So if we do run out of time before we get to your question, we will make an effort to follow up with you after the webinar. Okay, so this question is for Jim. And the question is for large projects. For the large projects that you talked about, how many field technicians were involved? And you mentioned that consistency was important.
Yeah, that's a really good question. In this case, believe it or not, I was the only technician that collected every one of those samples. So it doesn't have to be that way. I would say try to limit it to, you know, 1 or 2, because when we're looking at parts per billion, part per trillion levels, you know, just having consistent protocols is very important. So in this case, the answer is 1. I did have some help from a consultant on occasion, but I did all the sample collection. Great question.
Okay, this is just a related or similar question. It's asking, do you have an example of even with good SOPs that consistent personnel is still critical?
You know, I don't have any specific examples. I know that we see a lot of variability in data. So, I mean, there's no concrete evidence, but I have observed, you know, a lot of times now I'm being hired to provide oversight, and we'll go out and observe, you know, sampling done by others. And I see even within, you know, a company, if it's a large enough project, they'll have 2 or 3 technicians on site, and you see slight variances. Does it manifest itself in the data? I can't say, but I do see differences even if you have SOPs just on exactly how the work is done. But that's a very good point.
All right, let's see. This is a question for Jordan. And the question is, what color choices does retro coat come in, and is the surface slippery?
Great question. Since retro coat can be the wearing surface, oftentimes the building owner is going to want to know what aesthetic choices they have. We can certainly meet the needs of a specific color that they request. We have a standard color chart that we can provide interested parties. It is a very slippery surface when it's installed, so there is the ability to incorporate an aggregate to reduce the slippery nature of the retro coat system. So we are able to work with whatever the end user's requests may be.
All right, great. So next question here. This is a question for Jim, and it's regarding selecting laboratories. What are some tips on selecting a quality lab?
Yeah, I think as you remember, I said that's probably, in addition to the sample collector, what's most important. It gets back to experience. So unfortunately, there's a lot of labs out there that have done IH, industrial hygiene work, and it doesn't mean that, you know, they are proficient at providing the TO15s and some of the stuff that we need for indoor air or soil gas. To me, it really boils down to the hardware. So if you get hardware from a laboratory and you're doing your leak tests and they're failing consistently, then, you know, to me, the lab is only pretty much as good as the hardware that they provide, because if you're NELAC certified analytically, most of them are going to be sound. So to me, it really gets down to the hardware. Where's the flow gauge? Is it on the can? Is it on the SUMA, you know, or on the flow controller? So it's really a hardware question to me as much as, you know, the analytical.
All right, great. Let's see. Here is another question for Jordan. And the question is a 2-part question. Is retro coat expensive, and does it take a long time to apply?
So expensive would certainly be a relative term, but I can provide some budgetary ranges in terms of what to anticipate for a typical installation. Again, existing buildings are going to have their own challenges. If we're dealing with a wide open, large warehouse where you have access and are able to do the installation all in one swoop, that's an ideal situation. Installation cost, including, you know, the prep and the installation of the materials by a certified installer, can range from $1.50 a square foot, maybe up to $4 a square foot. Just for that labor and installation component. Materials, that's going to come down to which primer is required, and then if the end user is wanting that top WB system incorporated as well. So material costs can vary relatively widely, anywhere from down to $3 a square foot up to potentially $6. So that's kind of where we would fall.
All right, thanks, Jordan. Let's see, next question here. This is a question for Jim, and it's regarding removal of the household products from the homes. And the question is, how do I know which chemicals or products to remove? Is there an EPA recommended list?
Oh, that's a great question. And what it really boils down to is I'm not aware of an EPA, required list or recommended list because there are just millions of different combinations out there. So my opinion and advice is always err on the side of removal. So basically all we would leave is Clorox, not even hand soap. It is very invasive. So part of the problem is not only you having to deal with the chemicals themselves, but a lot of like the air fresheners may not have toxic chemicals in there, but they may have a lot of others that raises detection limits when the lab goes to run the TO15. So sometimes detection limits are raised for the entire analytical suite, which would mask some of the other compounds you should see. So there are some EPA databases that you can look at if you know the name of your product. If you have Gooby Gone and you want to know what's in there, you can go to a website and it will list some of the chemicals, but I'm not aware of any master list that the EPA provides.
Okay, thanks, Jim. Let's see, this is another question for you, Jim, and it is, how are the helium checks conducted, set up, equipment, etc., and how long was each helium check?
Yes, so for these projects, that's a good question. I have my own helium shroud that I've developed it's really, I'm not going to be able to answer this question in detail in the time we have, and it's really more about schematics. But needless to say, you have a helium shroud. You should be using ultra pure helium as the source, a helium meter, because you're having to measure the concentration of the helium in the shroud. At the same time, you're collecting a soil gas sample, which is typically done in a Tedlar bag. Use then the same helium meter that you measured the helium in the shroud to measure the concentration in the soil gas. It's really not a timed issue in my opinion. My opinion is I try to use half the volume of the Suma canister I'm going to be collecting. So if I'm using a 1 liter Suma can, I'm going to withdraw about 500 milliliters of soil gas while that shroud is full of helium and use that to check for the presence or absence. So there may be some states that have specific guidelines that I'm not aware of. My rule of thumb is about half the volume. So not that I think you should, but if you're using a 6 liter can, you're going to have to draw a lot more air to check for the helium leak test. But that's just my personal guide, and that's all I can say right now. But I'd be happy to discuss it later, with others.
All right. Thank you very much, Jim, and thanks, Jordan. That is going to be the end of our chat questions. If we did not get to your question, someone will make an effort to follow up with you. If you would like more information about vapor intrusion services from Total Vapor Solutions, please visit totalvaporsolutions.com. And if you'd like to learn more about vapor mitigation technologies from Land Science, please visit landsciencetech.com. Thanks again to Jim Fineis and to Jordan Knight, and thanks to everyone who could join us. Have a great day.